Welcome to No Diagnostic Required, a monthly look at what's happening in the C++ community. I'm Phil Nash, and I've got a confession to make. I forgot to record the video for the first 30 minutes of this episode, so rather than re-record it, we just decided to keep it as it is, and we'll just have slides at the start, and then bring the webcams in when we get to them. So with that, we'll drop in at the point that I ask Anastasia how she's doing.
Good. Actually, swam 38 kilometers during the recent couple of weeks, so a little bit tired. How are you?
Yeah, I'm okay. I'm just wondering how you got back from that.
That was just a summer fast in JetBrains we were doing in the company, so it was fun. I never had, a summer fast online when you can't actually meet the people, but you do some activities together. So yeah, that was fun.
Okay, yeah, I still have questions, but we'll move on. So, I'm afraid we've done it again, and this is the June episode, but it's sort of slipped to beginning of July. That is unfortunately one of the dangers of targeting the end of the month when we do our wrap-up. But this time, I think I do actually have a valid excuse. So not only did I change jobs last month, and more on that a bit later, but I ran a conference, C++ on C. And Anastasia, I think you were there at the conference as well. So how was C++ on C for you?
Yeah, I did a half-day workshop, not a full-day workshop, but still lots of preparation. I guess I spent quite many time on preparing that one. And that was actually my, longest workshop I've ever done. So I was a little bit afraid of doing that for the first time, but it went good. It was dedicated to code analysis in modern C++. We've covered a whole bunch of tools and a whole bunch of approaches there. It was interesting. I guess I had something like 7 people maximum there, but it was a very nice conversation during the whole half day. So how was the rest of the conference?
Yeah, it was good. I think it went pretty well overall. And having those half-day workshops was one of the new things that we tried. We tried quite a few new things this time because we wanted to change the format up a bit, because I think people are getting a little bit tired of the same online conferences now. Some things worked, some things didn't work so well, I think I have to say. But one of the things that didn't work so well, I think the numbers were a little bit down this year, but I think that's mostly because about 2/3 of the program was the workshops, whether it's half day, 1 day or 2 day, which was great that we actually had quite a few people there for the workshops, but it did mean that not so many people came for just the traditional talks, even though that was a longer day. So we still have 12 videos from the talks to release on YouTube in the near future, in the next few weeks. So watch out for those. The workshops weren't recorded, so they won't be going up. But talking of conferences, there's a few more coming up, of course. Well, there always is. But a couple to mention in particular. CPPP, that's the one in Paris. I can't remember what all the other P's stand for. That they cancelled last year, caught out by the pandemic, of course. But this year they're going to be running, but fully online. That's going to be in December. And their call for speakers has just opened. So now is the time to put yourself forward for speaking at CPPP. So it will be online, not actually in Paris. You don't have to speak French, but if you do, you can actually do a talk in French as well if you like. And then CPP-Con will be in October this year. I think we mentioned that before. And the call for speakers for that is still open, but only just. As I say this now, I think we've got about another week, maybe a week and a bit to go. So by the time you're hearing this, you probably don't have much time, if any. But yeah, check that out. But registrations have opened, so you can already buy your tickets for that. And that is planning to be in person as a hybrid conference. So there'll be, I think the idea is mostly an in-person component, but also an online component as well. So that's going to be interesting. I think probably one of the first hybrid conferences in our community. So it'll be interesting to see how that goes. Do you have any thoughts on CPPCon this year, Anastasia?
Yeah, I think it would be a very interesting experience, taking into consideration it's a hybrid. So I don't think our team will be going in person, but we'll try to join online event for sure. I actually submitted a couple of talks for a call for paper submission, which actually, yeah, indeed ends, I guess, July 19. So if you have a topic on anything C++ related, like hurry up. The interesting thing I spotted in the announcements, they actually made quite a few announcements in June, and one of that was that Bjarne will be giving a live keynote, so presenting and opening the CppCon this year. So he will be presenting live in Aurora City, and the talk will be dedicated to C++20. And the announcement actually interestingly mentioned his book, The Design and Evolution of C++, and it says that C++20 now seem to contain all the features except the unified function call syntax from this book. So which makes the keynote especially interesting. And also the interesting point is that right now is exactly the time when C++ features are finally appearing in the, practically in the major compilers. So that's the time when you can actually start using the C++20 in your real projects. So it would be really interesting to see the keynotes and to listen to Bjarne. So yeah, waiting for that.
Yeah, it's going to be an interesting conference, whether you can get there in person or just watching it online. So I'm definitely looking forward to that. Now, talking of things beginning with CPP, there's a lot of those, but another podcast, you may have heard of it, CPP Cast. A few times this has happened where we've talked about something on this show, and then I've found out that they just covered it on CPP Cast. But this time I'm getting ahead, and I actually know in advance that there's a couple of things we're going to cover that they've already talked about just recently. But that happens because we're in a monthly schedule. They do weekly, so they usually get ahead of us. But I did notice recently, though, they finally recognised us as the other regular C++ podcast. So
yeah, they had some discussions on that, I guess.
Yeah. So the first article that I know they covered recently, we're going to cover it differently, is on safe formatting. So this was a blog from Viktor Zurevich, who is the author of the FMT library, which has become standardized as a STD format. And that library is still evolving and still feeding into the standard. So actually, he mentions there's a new proposal that was accepted. I think we talked about it back in February, actually, P2216, about the compile time format strings. So if you provide a format string as a string literal, that can actually be type checked at compile time now in the library. And once this proposal has been accepted, then or applied, shall I say, that will be in not just C++23, but actually applies back to C++20 as well, because there's no reason not to. So that's quite interesting, quite a big feature to go retrospectively into the standard. There's a couple of things in the article, though, that struck me. One of them was where he talks about, in fact, I'll read the quote, formatting facilities in languages other than C are usually type safe. For example, in Python, you get an exception when trying to format a string as an integer. So it's comparing here to C's printf, which is, before STD format, the only way to do format strings in C++. So it's actually strange to think that until recently, Python was actually more type safe than C++ when it came to string formatting. Something to think about. He also mentions in there, and it was something that was picked up on CppCast, that he was quite surprised that the compile time overhead was fairly minimal. He was expecting it to add a bit of a drag on compile times, but no, so it's within the margin of error for different build runs, which is a nice segue onto the next article on CPP-LIT, which is library include times, so measurements of all the standard library headers. This is just on Windows, so it's not necessarily going to be true for all standard library implementations, but yes, definitely some key offenders there for adding build times when you include standard library headers. One of them is std format. Actually has quite a big compile time footprint. So maybe it's not so surprising that the extra feature didn't add too much to that. But what do you think about that? Any extra comments?
Yeah, actually, there in
these?
on GitHub where the library is described, I would say that there are a very interesting description for the conditions in which the measurements were taken. Because, like, every time you look at some measurements, the first question you ask, how did you actually measure there? Because you want to reproduce, you fail, and then you start digging into the into the conditions. And the very first thing they say there was a little bit controversial to our team when we were discussing that, as they were actually measuring the kind of the baseline, the lower limit of the header inclusion, because they were not actually using the headers, so just including them. And so times might become significantly bigger, as they say, if you try actually using, especially they have a templated code. So this baseline is maybe not really very practical. I mean, like, if you include something, you'll likely use that. And they are also using the O2 optimizations, I guess, in the actual compilation line they put there. So it might sound like this baseline is really unpractical in that sense that you don't know how to use that. So you usually use the headers, and so that's where the compile time is actually coming from. But yeah, still makes sense to measure something, because I don't know how to measure with the usages, because the usages could be completely different. I mean, you can use the whole header or just part of it, and it changes the compilation time significantly. But overall, the rest of the conditions were kind of more reasonable to me. I mean, they were saying that they were measuring the sub-includes as they were included for the first times, which totally makes sense. So that's the worst case in that sense, not the best one. And they were definitely measuring without any like caching. And for the release builds with C++ latest flag. So, and yeah, the actual measurements were taken with Visual Studio 2019, I guess. So if you want to reproduce, just take that. So yeah, but this baseline condition looks kind of interesting to me. I mean, like, how the things actually changes in practice. So yeah.
Yeah, I see where you're coming from. That it maybe doesn't sound so useful if it's not including usage. But on the other hand, I think what this is really setting out to do is literally to measure the impact of the inclusion model, because it does compare it to the module inclusions or imports there, which were basically just little blips on the chart, milliseconds compared to hundreds or even thousands of milliseconds for some of these header inclusions. So it does achieve that purpose of showing that using modules could be quite a significant save on compile times, particularly if you're using a lot of these more heavy headers. So yeah, you need to understand what the constraints are. I agree. Well, talking of standard library headers, that takes us nicely on to standards news, where we do talk about upcoming standards, of course. And the big news this month is that we had another plenary session. That's the session where the committee gets together to vote things into the standard. And Herb Sutter's trip report of the plenary session always amuses me when he calls it a trip report, but he didn't actually go anywhere. But old habits die hard. So his trip report covers some of the highlights of that plenary session. But before we get on to those details, actually struck me in some of his introductory remarks. He mentioned, but he actually said, we continue to have the same priorities and the same schedule we originally adopted for C++ 23. So despite all the changes of moving online because of the pandemic, and also the changes to the structure of how the meetings are run, they moved more to a monthly meetings rather than quarterly. And a lot of things have gone slower as well. So people have asked, is that going to change how we actually run that schedule? But No, it's saying all the priorities are the same, the schedule is the same. And one of the consequences of that, if you look at the schedule itself, the links from there, the next meeting, the one coming up in a few months' time, because we just had the last one, the next one will actually be the last meeting to approve C++ 23 features. The last meeting for new C++ 23 language proposals that we haven't seen before. So if you've got any new features to go into the language, the next meeting is the last chance to bring those up. And also the last meeting to approve C++ 23 features needing library response. So we're already getting towards the end of the C++ 23 cycle in that sense. And the meeting after that, C++ 23's design should be feature complete. So pretty much locked down at that point. It's just wording and defect reports and tweaks here and there. And they usually manage to slip a few extra things in as well under the guise of bug fixes. But basically, it is feature complete by that point. So we only seem to have just got C++ 20 out the door. Most compilers only support half, if that much of it. And we're already talking about finishing C++ 23. So yeah, it seemed like things have been moving slowly, but actually we're getting quite far into that.
Yeah, maybe that's intentional, to let compilers, finish the C++ 20 and, slow down the new things so that they can actually, stay aligned. I don't know, but it looks too early to me indeed. But taking into account, we still don't have the big C++ 20 things in the major compilers. Mm-hmm. So that might be reasonable.
Yeah, no, I've said before that I think having C++ 23 be mostly some people call it a bug fix release. It's not quite right, but more of a catch-up release, I think. Just rounding things out, fixing things here and there, yes, and just maybe adding some little features, but nothing too big. I think we've had enough big features for a little while.
Yeah. Agree. Yeah. Actually, I was talking about that at my workshop at your conference, that having quality releases is good enough.
Yes. Yeah.
They make sense.
Quality release is a better term. Yeah.
Yeah.
That meeting after next that I mentioned, the one where the design should be feature complete, they're also planning for that to be the first in-person meeting, back in person. If so, it will be in Portland, Oregon. So that's quite exciting. It'll actually be 2 years since the last one, the last in-person meeting at that point. So hoping that's going to pan out, but obviously that's dependent on a lot of unknowns at this point. Okay, so the first proposal that went in that I wanted to bring out was P1938, which is the one that talks about it's if consteval is the feature being proposed, and it basically does the same thing as if is constant evaluated, which is a little bit difficult to parse verbally. So if you're watching this on video, or you have a podcast player that can show chapter art, I'll have that up on the screen. But you can do a condition to say execute this branch if we are in a constant evaluated context. So you can maybe have, say, 2 different versions of an algorithm, one that's fast and optimized, but not really suitable for compile time for some reason, and then a simpler one. We don't mind if it takes too long because it's all going to happen at compile time anyway. That's quite a common usage for this sort of thing. Now, you've been able to do that since C++ 20 with this is constant evaluated. The trouble is the natural way that people want to write it is to say if const expr is constant evaluated. And the trouble is that's exactly wrong. Because by the time you put the const expr in there, you're already in a constant evaluated context. And so it will always be true. So it just doesn't work. So that's the main motivation for this paper, which actually was It was proposed in the C++ 20 timeframe as a defect report, I think. It didn't quite get in at the time because it's thought, well, we can live with what we have. So they just wanted to get it in now to fix that problem. There's a couple of other consequences as well, because even if you do get it right, there's still some things you can't actually do in the if part. When you say, well, I am in a constant evaluated context, but by the time the parser gets to see it, before it's been that the path has been chosen, it has to evaluate certain things. So if you call another consteval function and you pass it an argument that depends on, say, an argument you've been given, a constexpr argument, it may or may not be compile time. And if it's not, then it will fail to compile. So that doesn't quite work either. So this introduces a different type of scope, this if consteval, which doesn't have that problem. It's the parser doesn't actually see it until after it's decided whether to take that path. So it just happens at a slightly different stage of the parsing. So it really is a bug fix, really, although it is a new language feature. And then some people have asked, well, are we going to deprecate is constant evaluated? And the answer to that is no. Partly because there's still valid reasons to have it. Like if you want to say is constantly evaluated and something else, then being able to have it that way is useful. Although you can write it yourself. You have write your own version of is constantly evaluated in terms of is const eval. The trouble is, then lots of people will do that, and there'll be all these different versions around. Simple enough, but because we have this problem with if constexpr and is constantly evaluated, compilers are starting to warn about that usage. And if we don't have a standard version for them to warn about, then they'll have to be even more sophisticated to warn about people's ad hoc versions instead. So that's probably not the best kind of worms to open up. And on that note, actually, going back to C++ on C, one of my new colleagues, like Jolie, did a demo of SonarLint at the conference, and he actually used exactly this example, the if constexpr is constantly evaluated, and just showed how SonarLint actually not only catches that, but actually gives quite a good error message or a warning telling you exactly what's going wrong. Whereas some of the compiler warnings, yeah, it warns you about it, but it's not immediately obvious why it's warning you. So it's definitely a problematic case to be in the language. So good that that's been fixed, even if it's not terribly exciting. It's just an example of the quality release. I think it's a good way of putting it that we're looking forward to. Do you have any opinions on that?
I haven't actually dig deeper into it, but I think that's indeed a good place, for tools to step in and to help with some things here until you get a proper fix, maybe in the language.
Yeah, it's a shame in a way that it sort of happened that way round, given that this was detected quite late, unfortunately, in the cycle for C++ 20, but before it was finalised. But as we said, there is a use for the is constant evaluated version as well. Okay, well, moving on. P1659 starts with and ends with, which we got previously as member functions for stood string. Really useful basic functions that I'm sure many of us have written our own versions of at different times. Of course, when we've written our own versions, we've probably had to write them as free functions because we can't write our own versions of standard member functions. So it seemed like a good thing that they got put as member functions onto stood string. Well, that's not what the author of P1659 argues. He thinks that they should always have been free functions because that's actually a better way to extend standard library features with algorithms. And even goes as far as to propose that SD8, that's Standing Document 8, which talks about compatibility. So introducing features into the language which may break source level compatibility with previous versions of the standard, advice for minimizing that, or when it's when it's that's acceptable or not. He's proposing adding a bit in there about always preferring non-member algorithms. In this particular case, he's proposing them to be added as range algorithms, which makes sense these days, of course. Now we have ranges. So that means you'll be able to use them not just with strings, but with any sequence that can be expressed as a range. And he gives examples with std iota of sequences, which is fair enough. And not only that, but you can also specify what operator gets used in the comparison. So it's not just an exact match. It starts with exactly these characters, but you can also do less than or greater than comparisons as well, which I can't personally think of a use for, but it's nice that you've got that flexibility. Why not if you're adding the new feature? So let's hope it starts with and ends with that. And then a final one to look at. P2166 talks about how we can construct, again, std strings. Strings get a lot of a look in this one. You've always been able to construct a std string from a string literal or a pointer to a sequence of characters. Trouble is, if you passed it null, that's always been undefined behavior, and different implementations do different things, which always exacerbates the situation. So it may or may not crash. And this paper sets out to fix that in a very small way, which is if you pass it the null pointer value, so known at compile time to be null pointer, then it will fail to compile, which is great. And on the surface would seem to be, well, who would actually do that anyway? Well, it turns out quite a few fairly high-profile libraries have been doing that. They found cases in the LLVM source code, in POCO, in its ODBC implementation, even in Protobuf. They all had cases where std strings were being constructed from null pointer that was known at compile time. And it particularly comes up in generic code. I think some of the examples were generic. So you can't actually see by looking at the code that that's what's happening, but it is known at compile time. And so it's good that can actually be detected. It would be nice if we could make it impossible to do it even at runtime, but that ship has sailed, unfortunately. But any thoughts on that one?
Yeah, I just want to say that any cases when we do eliminate undefined behavior are actually great, because I should say that that's probably the biggest point of developer frustrations in C++. So,
it is.
Yeah, even a small case is better than nothing.
And it is an interesting tension, I think, in the evolution of the language. We often say that C++ allows undefined behavior so that we can wring the last bit of performance out of something on the basis that, well, we just write our code in such a way that undefined behavior is never invoked. But of course, that's much easier said than done. But over time, we're getting more and more features in the language that make it impossible for us to actually invoke it. So it's there, but we can't get to it. Unfortunately, there's still many, many cases where that's not the case, but it would be nice if we can actually make more headway in just making it not compile if you are going to invoke undefined behavior, while making it theoretically possible, as in not having runtime checks prevent it. Move those to compile time checks would be a good direction, I think. But yeah, again, easier said than done, I think.
Yeah.
Okay. So that's the end of the standards news for this month. So tools news is up next. So over to you.
Yeah, thank you, Phil. Actually, there is a nice connection with talking about the undefined behavior. since there is a lifetimes proposal, which is also working on that. I mean, like eliminating these undefined behaviors from like tangling pointers and null dereferencing and like escaping from local scopes, all these things. We talked about that early in May when we talked about the CLion opening the 2021.2 AP program, where we started implementing the lifetimes analysis. So we're still on it. But this time, like in June, we were more focused on debugger enhancements. So, and it seems to be that these enhancements are actually trending among our users. So I did a quick poll in Twitter asking about the favorite fixes, the favorite changes in the recent AP, and the debugger was definitely trending there. So it's very interesting to see. So, one great feature there is an opportunity which we called relaxed breakpoints. So they are relaxed in the way that CLion is using the base name or the source file instead of the absolute path. And this is very useful in case where the path mappings are too complex, and so you kind of don't want to fill them in all the details in the debugger configuration. But like the source file names are still the same, so it's just some paths mappings which doesn't work accurately. So the relaxed breakpoints means that you say like, okay, so use the source file name to detect where it is stop, and it now works in CLion, so you can switch any breakpoint to the relaxed breakpoint now in the UI. The second thing which I personally really like is a very, I would call it a small UI thing that really changes the world you debug, because that's about the preview tab. It was recently, it was previously introduced for other features in the IDE, but we now enabled it for the debugger. So that means that it actually saves the editor from polluting with too many tabs, because when you are stepping actively through the code, like a new tab is all the time is open for you in the editor, and by the end of the debugging process, you're just stuck with quite many tabs opened in the editor. So if you enable a preview tab, everything will be opened for you just in a single tab. So and the name will be like updated there, and you will see that single tab which opens the file every time you step into it. And that's more convenient, I guess, in terms of the UX. So just a very small change, which makes the experience completely different. And finally, there were some changes around the LDB. So first of all, we made the GDB remote debug, which was previously introduced like several years ago. We also enabled the LDB version. So you can now use the LDB remote debug there in CLion. And also on Windows, you probably know that CLion is coming. It comes with bundled LDB-based debugger implemented by the JetBrains team for the case of the Microsoft Visual Studio toolchain. So we're using this debugger in CLion and in Writer for Unreal Engine to debug the code compiled with MSOC. And this debugger actually got a massive overhaul with the significant improvements targeted on NetWiz customization support. So there are lots of changes for general C++, NetWizes, and also for Unreal Engine in Writer. So, and we've heard many good feedback about that. So if you're using this toolchain in CLion, you'll definitely have to check it out. So there are lots of interesting things. And I guess that's mostly it about the CLion update for this month. And coming to the next tool in the family is definitely ReSharper C++. So, and I would like to mention only one big thing here, but it's really very valuable. It's the inline function refactoring. So, it's always good to have the refactoring working in both directions. So when you can do the refactoring, and you have the opposite one. So when you have the extract method or extract function refactoring, the obvious opposite action is inline function. So now it also works in ReSharper C++. So assume the function body is quite obvious, and you want to make sure the code is maybe more straightforward and easier to read, and just minimize the number of extra function calls. And so you just do this inline function refactoring. I have to say, it's not always possible. And in that case, the ReSharper C++ will warn you. So it will just tell you that, yeah, for example, I cannot inline the virtual functions, or I can't do this inline refactoring. So you will get a proper message that the refactoring was not possible. But when you get the refactoring, actually, you will benefit from the fully automated approach. So like definitely the code transformations will be performed, and the name conflicts will be handled for all your variables, and also the resulting code will be reformatted. So you get a proper code refactoring with that, and then you can proceed with further like cleanup of the code or whatever you're doing there. So there are other changes in the AP for ReSharper C++, but I think inline function refactoring will be the biggest feature delivered in 2021.2 for ReSharper C++. And also have to mention that a couple of days ago, I posted in my Twitter, I posted the call for those who've never tried the ReSharper C++ or ReSharper for the UX study. So if you would like to participate, you're very welcome. Just find the link in my Twitter. And join us. We would like really to improve the experience coming from the tool. And we're looking for those who've kind of like working on Windows in Visual Studio and never tried ReSharper C++ or ReSharper to like do some UX study with us. So
yeah, I don't qualify for that.
Yeah, probably not. You've seen quite a lot from the tool. So yeah, we're looking for those who are new to us, so that they can try and like share their, first impression of how these standard things are going for them for their projects. Yeah, and I think this news, I don't know who is the better person to cover it, because that's about the SonarLint plugin, but for CLion.
Yep.
Have you tried it, by the way, Phil?
Let's fight over this one. I haven't actually, not in CLion. I have actually been trying it in just about every other context so far, but that's the next one.
Yeah, let me introduce this then. So I actually played with it recently. So in general, like the code analysis abilities in CLion, they provide you with many opportunities to catch like, various types of errors and possible inaccuracies in the code. So there are basic compiler checks and the data flow analysis on all these lifetimes checks. We were talking in May, like some MISRA specific checks, but also if you look at the like native built-in abilities in the CLion, you can also find that there are some third-party plugins which kind of strengthen the code quality protection in CLion. So for, I guess, from the very first days of the CLion ID, there is a CPP check plugin with some slow but still contribution into it from the community. But now there is also a SonarLint plugin. So if you're interested in using the Sonar source linter in CLion, so you can check this free plugin. So install it from the plugin repository. So you can do that right from the IDE. And it brings like lots of checks. There are also like MISRA checks and the C++ core guidelines checks. I was playing with the plugin before doing my workshop at C++ and C because I was referring to Sonar source tools, mostly in the context of the CI integration and all these, pull request checks and code reviews, related code analysis. But the SonarLint plugin just on its own, is also just a good linter which adds some value to your building code analysis abilities in CLion, and it's free, so you can actually play with it. And the recent version was exactly released in June, and so you can see how it works. I guess the plugin itself, not the linter, but the plugin itself is open source, so you can even maybe contribute to it and add some values there as well. So, and I hope that Phil will play with the plugin, will submit some feedback to us maybe as well.
Yeah, just in case it wasn't clear, because I didn't mention it explicitly, but Sonar Source is where I've now moved to. So
Yeah. So yeah, I'm just getting a little bit here and trying to think. So there is also another plugin which I have to mention here, since we started mentioning the third-party plugins for CLion for code analysis. Actually, the topic is really, really hot, so I think I would just select the proper time for doing the code analysis workshop. So there is another plugin in place from PVS-Studio. It's open now for free beta testing. So the overall analyzer, I guess it's not free. There are just some cases when it's free. But anyway, you can sign up for the free testing. There is a plugin and also a separate analyzer, which you'll get a trial key for. So there are also some Mistra checks and some general C++ checks. And I guess PVS-Studio are quite often blogging about their code analysis checks on various resources, so you probably have heard about them. So yeah, there is like a selection now of interesting code analysis plugins for CLion. So you can get the native functionality built in, plus all these like fancy plugins, and you can actually build a plugin on your own. So the API is open. So if you have a code analyzer, some linter, you can actually also integrate it into CLion and see the checks in the editor, which is, I guess, that's great, like having all this ecosystem evolving in this direction. And actually, talking about the PVS-Studio, I spotted another interesting news from them. It was coming in the, I guess, end of May, beginning of June. So about their switching to Clang to compile the actual analyzer on Windows. Actually, it was not just the Alvim Clang, it was Clang CL, I guess. So they were previously using the MSVC toolchain, obviously, and they switched to using Clang CL compiler, also from Visual Studio installation. And the very, very interesting insight was that that change, like the just simply changing the compiler, actually improved the performance of the analyzer by, I guess, 13% was mentioned there in the blog. That's really surprising me. And there are also an interesting outcome in this blog post in the form of a list of things that actually went wrong and they had to correct while they were switching to Clang CL compiler. Like, for example, they were using int 128 type, which is supported out of the box in GCC and Clang and was not in the MSVC. So they had to update some per processor definitions, and they had to fix some alignments because they were getting some segmentation fault errors. So yeah, there is some interesting story behind this move to the Clang compiler. And that reminds me that actually changing the compiler, is not an easy step. And especially when we talk about the Clang on Windows, I have to say that our team actually knows the pain. So we had some slightly related, but a little bit different experience when we were setting Clang with MinTWV64 toolchain in CLion. We, I guess, even blogged about it in our blog. And there were also lots of interesting observation how to cook the proper linters and all the tools there. So yeah, if you're like willing to use Clang on Windows, you have to, follow some tips and tricks here. Yeah,
that surprised me actually. Obviously, they did hit some fairly gnarly problems, but for porting a mature code base from Microsoft compiler to Clang CL, it actually seemed fairly easy. I thought they were going to hit more, but maybe they glossed over some things. Who knows?
Yeah. Yeah.
It also surprised me the speed up they got. Obviously, it depends what you're doing, but generally the Microsoft compiler does have quite a good name for performance. So that was quite an interesting result. Although it did impact their build times. I think they got a bit slower, didn't they?
Yeah, the builds were slowed down, I guess, by 8%. Probably they were mentioning. Yeah. They were not getting into much of the details of their performance improvements, but there are just some tips for that. So I'm not sure. Maybe they will blog later about all the details. But yeah, indeed, the build times got worse but just not 8%. I mean, it's not big, so yeah. It's fine.
They get that back the first time they run it.
Yeah, that's true.
So finally, then, what can C do that C++ can't?
Yeah, I guess this time and finally, thread is my favorite one on Reddit during these months. So there was an actual thread on Reddit, which was like, I guess it was started in early July, but since we're a little bit late for June, I decided to add this one to incorporate it because it's really a very funny thread. So the question asked there is if after C++ 17 there is a single C feature not possible in C++. First of all, surprisingly, I guess nearly the only actual language feature mentioned in this long thread was the designated initializers, which were actually delivered in C++ 20. They are a little bit different from what we get in C, and there is, I guess, a link to more details in the thread, so the people were discussing it there. So there were a few people mentioning the designated initializers, but that probably was the only language feature. All the majority of the people there were mostly talking about the surprisingly ABI. So it seems to be a hot topic now in the community. So yeah, they were mentioning the stable cross-platform ABI as the only thing they now miss, and that's all interesting in the context of the general discussions in the C++ community about breaking or not breaking or how to break it properly. The C++ ABI. All this, like when you hear the ABI word that many times, you start thinking that probably it is that important. But yeah, that's a funny thing. Obviously, there were quite common things mentioned in the thread, like the simplicity, which is quite often mentioned in the context of the C language. And there were people targeting noticing that C++ is also trying to move to this, simplicity goal right now with some recent proposals trying to make the language simpler. Also, the thread was mentioning the C bindings for many other programming languages, which is the obvious thing you usually have, and also maybe good point mentioned there was the compiler support for the niche platforms and especially in the embedded compilers. So because the C++ compiler is much easier to implement, you quite often get it on all these platforms and all these embedded platforms, but not the C++ compiler. With C++, you more or less have some issues to get to the point. And yeah, as usual, the faster compile times. I mean, they were mentioned quite many times there. And not that you can't get the same with the C++, but just the point that it requires much bigger effort usually than in C. So yeah, just all these, typical arguments. And my favorite one was probably the answer that you can spell the name of C with a single keystroke. So yeah, that's probably the biggest argument there after the ABI and compile times. What about you? Have you spotted anything interesting in the thread, Phil?
Well, you mentioned the very few language features I mentioned that were different, as well as designated initializers. I also saw val array and restrict was the other one. And interestingly, all those features, because most C++ compilers, in fact, all the mainstream ones, are also C compilers, just with a different switch. They support all of those by extensions anyway, which can be a bit of a problem sometimes because you can start to rely on them in your code, especially things like, I think the designated initializers. The differences are more to do with you can reorder the ones in the C version, I think, but not in the C++ version, except most compilers will let you reorder them in the C++ version because you can do it in C. And then, of course, you're running against a different compiler and it will fail because that's not the way the standard dictates. So you can get into trouble with that, which I suppose is another argument for C.
Yeah. But yeah, overall, the thread is very interesting. And maybe you can also throw there a couple of answers if you have some words. Yeah.
Yeah, well, so that's it for this month. Well, for last month, really. This month is not done yet. So we'll try and get back on track next time. And again, if you have anything that you'd like to see on the show, any particular community news, do let us know. But until then, we'll see you then. Bye.
Yeah, see you. Bye.